Hello again, it's Cal from Wise Guys Tutoring, and today we're going to be doing part 5 of the EmSAT Math 2022 practice questions. As usual, I'm going to try to give you a background on each topic while we solve the questions so you have a good full understanding. So let's get started. First question. For a given time, x in seconds, an electric current y can be represented by y equals 2.5 times bracket 1 minus 2.7 to the power of minus 0.1 or 0.10x. Which equation is not equivalent? So you can sort of ignore the physics there and we can just focus on the equation. So let's go through these one by one. We'll notice that each of them has this 2.5 minus 2.5 times something. So what they've done here, let me rewrite it. They've expanded it. That means they've multiplied out that 2.5 by both of the terms inside the bracket. So it looks like this. So 2.5 times 1 and 2.5 times negative 2.7 to the blah blah blah. So if we do that, then you get y equals 2.5 minus 2.5 times 2.7 to the minus 0.10x. Okay, so once you've done that, we can safely assume that A is correct. Okay, so he's safe. He's not getting chopped off. Now let's look at the second one. It's very similar, but you'll notice that they've changed the inside of this bracket. So this is a law of exponents that we should learn about. So for B, so let's say this is A. Now for B, what we need to learn here is that an exponent of an exponent, how do we deal with that? So let's say you have, for example, 2 to the power of 2 and the whole thing to the power of 3, right? I just want to show you how you deal with exponents of exponents. So what you do, here's the shortcut, okay? The shortcut is exponent of an exponent, you multiply them. So this would become exponent of 6, okay? And the reason is, here's the underlying reason. What's 2 squared? 2 squared we know is 2 times 2. Now this thing cubed means this times itself 3 times. So times again 2 times 2 times again 2 times 2. And you'll notice that we're multiplying 2 by itself 6 times. So that's where it comes from. But if you just want the shortcut, an exponent of an exponent gets multiplied. Okay, so in our case here for B, what happens? You have 2.7 squared to the power of 0.05x. So this means we are going to multiply those exponents. So this is equivalent to 2.7 to the power of 2 times minus 0.5x, which is in fact 2.7 to the minus 0.10x. Okay, so again, B is safe, right? Everything is the same. They just rewrote that exponent in 2 parts, but as we've proved here, it is the same, so B is safe. So for C, you'll notice everything again is the same, but this term is a little bit different. So here we got to learn about the property of negative exponents. So negative exponent just means to flip your base. So for example, 2 to the minus 3, what that means is you flip your base. Right now the base, if you don't see a denominator, it's always 1, right? So it's 2 over 1. The minus in the exponent doesn't mean make it negative or anything at all. It just means to flip it. It means invert it. So it's take the reciprocal and you can keep your exponent. Okay, so a negative exponent means flip your base. Okay, I'll give you another example with a fraction. For example, 4 over 5 squared, or to the minus 2 rather, means flip it and keep your exponent. Okay, another thing we should learn about here is that the exponent actually gets distributed to both. If it's a division or a multiplication inside, then my exponent will be distributed to both. Now 1 cubed is just 1, so this ends up being 1 over 2 cubed. So whenever you see a number, basically what I'm telling you, whenever you see a number to a negative exponent, you can just put 1 over that number and he can keep his exponent downstairs. In this case, it would be 5 squared over 4 squared. And this would be 25 over 16. Okay? But the point is that even if it was a multiplication here, I'll give you an example just to finish it off. Let's say it's 2 times 7 squared, right? This 2 would also get distributed to both because it's a multiplication, right? So this would end up being 2 squared times 7 squared, which is 4 times 49, which is 196. Okay, so in this case, let's go back to our guy here. He was 1 over 2.7 to the 0.10x. Well, since it's 1 over, that means if I make the exponent a negative, he can come back upstairs, right? He can get flipped over to be 2.7 over 1, right? But we don't really need the over 1, but we do need that negative. So in fact, minus 0.10x is the same as 1 over 2.7 to the 0.10x. So the negative exponent means go downstairs. It means flip your base, invert your base. Okay, so C is also safe. Obviously D is the culprit, but let's see why. This is the property we're going to discuss now. It's when you have the same base and you multiply. So let's say I have 2 to the 2 times 2 to the power of 3. So we saw earlier what you do when you have an exponent of an exponent, right? You have to multiply those exponents. In this case, it's not the same. Again, I'll give you the shortcut, but when you're multiplying the same base, you add their exponents. You add their exponents. So this would be 2 to the 5. And here's the reason why. If I was to break them down separately, this would be 2 squared is 2 times itself twice. 2 cubed is 2 times itself 3 times, right? So if I look at these 1, 2, 3, 4, 5, I'm just multiplying 2 by itself 5 times, right? So there you go. While we're at, so again, let's go back to our own example. So this was 2.7 to the minus 2x times 2.7 to the 0.05x. And if you're multiplying with the same base, actually you wouldn't have multiplied the exponent. You would have added them up. So this is 2.7 to the minus 1.95x, which is not what we had originally, meaning D is wrong. But one more side note here. See, when you multiply, you add the exponents. As you may have imagined, if you're dividing with the same base, then you would have subtracted. Subtract the exponents like this. So this answer would have been 2 to the 2. Again, if you want the real version, what's happening is 2 to the 5 is 2 times itself 5 times. And when I divide by 2 times itself 3 times, what happens is this 2 cancels out with this one cancels out with that one cancels out with this one, and what do I have remaining is 2 times 2, which is 2 squared. Okay, but here are the rules. Again, one more time. If you have an exponent of an exponent, then multiply those exponents. If you have an exponent, if you have a base times the same base, you add their exponent. If you have a base divided by the same base, then you can subtract the exponents, top minus bottom. And if you have a negative exponent, it means flip your base. Okay, we also learned that if something is being divided in a bracket and you have an exponent, or multiplied in a bracket and you have an exponent, then you can distribute that exponent. Okay, let's move on to the next question. So the expression 1 over x plus 1 over y over 1 over x squared minus 1 over y squared is equivalent to. So we're just going to have to simplify this. So it's a little bit algebra intensive, but it's basically fractions, and we'll try to follow the rules that we usually know. First of all, let's join the 2 on top, and let's join the 2 in the denominator. So if I want to add these, the problem is they have different base. So what I have to do is find the lowest common denominator. Unfortunately, between x and y, there's nothing common. So we just have to multiply them by each other. You multiply top and bottom to keep the fractions equivalent, right? That way we're just changing the shape of them. So the left one becomes y over xy plus x over xy. Now they have the same denominator, and I can join them. So I'll say it's x plus y over xy. That's the first, the numerator. Let's do the denominator, right? We'll do it in the same way. You have 1 over x squared minus 1 over y squared. So I'll do the same, but this time they're squared, but the idea is the same. You're trying to get the same denominator, right? We're not changing the fraction, we're just changing the shape so that we are going to be allowed to add them. You get y squared over x squared y squared minus x squared, yes, over x squared y squared. There's a minus here, be careful, so it's y squared minus x squared over x squared y squared. Okay, so part 1 is done. Now we're dividing them, right? And let me set it up here as a division. Here we go, over xy. The whole thing is divided by the bottom one we found. So it looks, it looks daunting, but it's not that bad. You just got to keep your steps clear. Whenever we divide fractions, we're not good at dividing, we're good at multiplying fractions, right? So you have to turn it into a multiplication. And instead of dividing by something, you multiply it. I think what people usually say is keep, change, flip, right? So you keep the numerator, you change the sign, and you flip this one. There you go. You flip the divisor. Okay? So it's like multiplying. Dividing by this is like multiplying by its reciprocal. Here you go. So now what we're going to try to do is simplify this a little bit. You can take the top one first. Okay? Now we just saw in the other question, in the first question, that x squared y squared. This is basically x times y squared, right? The 2 gets distributed and you end up like this. If you don't like thinking of it that way, think of it this way. X squared is x times x, and y squared is y times y. And we know that multiplication is commutative, right? So I can change the order, so I can make it like x times y times x times y. So it's basically x times y times x times y, which is xy squared. If you'd rather think of it that way, it's all good. But basically this simplifies to xy squared. The bottom one though, the bottom one is called a difference of squares. It's a particular case where you can simplify to y minus x times y plus x. And the reason is, if you were to multiply this out, you would get y squared plus xy, right? I'm doing y squared xy and then minus xy and then minus x squared. What happens is those two middle terms cancel out, and you're always going to be left with the first one squared minus the second one squared. That's why we call it difference of two squares. So you always take square root of this plus square root of that times square root of this minus square root of that. Okay? So now that we have the simplified forms, let's put them on. You have x plus y over x y. That was already simplified. Top one we'll say is xy squared over y minus x, y plus x. So now we look for common terms that we can simplify. Xy squared divided by xy. Now remember, when you don't see an exponent, this is 1, right? And we just learned that when you have dividing with the same base, you subtract their exponents. So this is going to be 2 minus 1. You're going to end up with just 1 xy to the 1 on top. The bottom here, you have x plus y, and you're dividing by y plus x, which is the same, right? Because addition is commutative, so 2 plus 3 is same as 3 plus 2. So this term will cancel out with this one. Remember, anytime you're multiplying terms in the numerator and you're dividing terms in the denominator, as long as you have the same term, you can cancel out like this. So what am I left with? I'm left with an xy on top, and I'm left with y minus x on the bottom. Meaning the answer is, unsurprisingly, number 1. Okay? Lots of algebra, but take your time. Get comfortable doing the equivalent fraction thing, and also dividing by fraction, and then simplifying as well. Let's move on to the next one. Okay, this says, which of the following distributions has a mean of 75 and a standard deviation of approximately 5? So we've talked about this, and I'll put the link again in the video. This is based on the empirical rule. In a normal distribution, it's called a normal distribution. That means your mean is right in the middle, and the standard deviations are telling me how far I am from the mean. The mean is 75 in our case, right? Whatever the mean is, let's put it here. And if I go one standard deviation to the right and one standard deviation to the left, in this little range here, in this little interval, I have 68% of all the values will be in here within one standard deviation. Standard deviation is marked by this Greek letter sigma. Now if I go a little bit further out, let's say to 2 standard deviations over here and 2 standard deviations over on that side, then now I have 95% of all my data. And if I overdo it and I go 3 standard deviations, so that's plus 3 on that side, and 3 standard deviations under the mean, well then here I have 99.7% of my data will be in here. Very few values or measurements or whatever will be above that and below that. Very, very few. Okay, so when we look here, they say the mean is 75, standard deviation is approximately 5. So they're asking for those ends that we're talking about, the plus 3 standard deviations and minus 3 standard deviations, right? So if one standard deviation is 5 and the mean is 75, so then this value here, in this example, this value here would be 75 plus 3 standard deviations. So I expect it to be 75 plus 15, that's 90. Whereas this one here will be 75 minus 3 standard deviations, that's minus 15. So I expect that one to be 60. Okay, so the answer is A, like usual. But the idea is this: when you have a normal distribution, the distribution follows this thing. It's called the empirical rule. This kind of distribution where we have 68% of the data will be between minus 1 standard deviation plus 1 standard deviation. So in our case, this would have been like 70 and 80. Let's say these are I don't know, the weights of some men or something. Okay, then this group of men, 68% of them will weigh between 70 and 80. 95% of them will weigh between 65 and 75. Sorry, 85 rather. And 99.7% of all the men in this group will be between 60 and 90 kilograms. That's what it means. So it's very helpful to know the standard deviation and these percentages. And this is actually given in the specimen paper equation sheet, so you'll get that as well. All right. I've also done a video, so I've posted the link. You can check it out. I spoke about it in a little bit more detail than now. Let's move on to the next one. Okay, here we go. All students at a private middle school are required to sign up for one of 3 clubs: chess, drama, or math. The graph below shows the distribution of participation by grade level. Which of the following statements is incorrect? Okay, so we'll go through them one by one and we'll see which one is correct and why and whatnot. Remember, these are percentages that they have here. The sort of tricky thing, I guess you can say, is that some percentages, like here the drama club, it doesn't start at 0. So you're gonna have to figure it out using the interval, which is okay. So I recommend let's just start right now by putting the percentages of each block, shall we? Okay, so the first one here is between 0 and 20. That's pretty obvious, 20%. Here between 0 and 30, so that's 30%. 0 and 40, that's 40%, right? Now let's do this. So here the drama, 6th grade drama, it's between 20 and 70. So to figure this out, I would just say it's 70 minus 20. So that one is 50%. This white block is 50%. How about this gray part? We'll do the same thing. It goes from 70 to 100, right? So I do 100 minus 70. That block is 30%. And we can check if we've done it right. You know me, I always like to check, right? They're supposed to add up to 100%. So 20 plus 50 plus 30 is 100. We're good. Grade 7. These ones go from 30 all the way to 80. So again, I do 80 minus 30. That's 50%. Okay. For the last bit here, it's 180. 100 minus 80 is 20. Again, they should add up to 100. So 30 and 20 is 50 plus 50. That's 100. We're good. Here between 40 and 60, you get the idea. 60 minus 40, 20%. 100 minus 60, 40%. Our check, 40, 20, that's 60, plus 40, 100. We're all good. Now let's check them. So it says, A says 30% of the 6th graders joined the math club. 30%, so math is the gray one. Yes, that one is good. Safe. I don't know why these days are making us like chop them off, right? One by one. I feel like we're on a game show. The number of 8th graders who joined the chess club is the same as the number of 8th graders who joined the math club. So 8 chess, which is 40, and 8 math, which is 40. Yes, they are the same. Well done. C says the number of 6th graders who joined the drama club is the same as the number of 7th graders who joined the drama club. So 6 drama, 50. 7 drama, 50. But here's the trick. They didn't say the percentage, right? Look, they say the number of 6th graders is the same as the number of 7th graders. That's not true. It's the percentage of 6th graders is the same as the percentage of 7th graders. But here's the problem, okay? What if I have, let's say I have 100 6th graders, so 50% of them, 50% of the 6th graders is just 50 people. But what if I had 200 7th graders, right? 50% of them is more. 50% of them is 100. So while the percentage is the same, we don't know what the numbers are. So C, you're fired. Boom. Okay, we'll check the rest just to make sure. So it says the percentage of 8th graders who join the math club is twice the percent of 7th graders who join the math club. So in 8th grade, there's 40% and there's 20% in the 7th grade. So yes, that is true. Percent of 6th graders who joined chess, which are here, the 20%, is the same as the percent of 8th graders who joined drama, 20, 20, no drama, all good. So it was C. That's what it was. It was trick. So remember, the number of 6th graders is not the same as the percentage, right? You don't know what the numbers are. The same percentage for both can mean different numbers, okay? And in case you're curious how I did this, if you want to find the percentage of something, you have to multiply. You multiply them. So 50% of 100 is 50% times 100, but you can't really put 50%. You have to change it into a decimal or a fraction. So this would be 50 over 100 times 100, or 0.5 times 100. That's 50% as a decimal, 50% as a fraction, right? 1 over 2. Yeah. Okay, let's move on to the next one. So this is a probability question. It says the probability that Ahmad smokes is 3 over 10. The probability that he smokes and develops lung cancer is 4 over 15. The probability that Ahmad develops lung cancer given that he smokes. Find the probability. Sorry, I missed that word. But basically here it is. The probability of him smoking is 3 over 10. The probability that he smokes and gets cancer, God forbid, is 4 over 15. So that's what and means. It means the intersection. Intersection. Intersection means both events happening, right? So smoking and getting cancer. That's what the intersection, it looks like an N almost, but it's an upside down U. Now they say the last bit is a bit tricky, right? They say find the probability that Ahmed develops lung cancer given that he smokes. Now this is a very, particular word when we are talking about probabilities, given that he smokes. So in this case, we know that he smokes. It's for sure that he smokes. So what's the probability that he will get lung cancer? This is how it works. Conditional probability looks like this. Probability of A given B. Okay, I'll write that so you guys can get used to it. This is probability of A given B. So that line is like given, right? Same as they told us here, given. And the equation is this. You take the intersection of both, so A and B happening, over probability of the given event. So if we replace ours, right? Probability that he gets cancer given that he smokes, right? We're going to say probability of both of them happening, smokes and gets cancer, divided by the given, which is smoking. So if we do that, we just have to punch the numbers in. We already have the intersection, right? Probability of both is 4 over 15. We have to divide that by probability that he smokes, which is 3 over 10. Okay? And if you put that in your calculator, you will get 0.8 recurring, which is 8 over 9. Okay? Just one last word about this conditional probability. Basically what we're saying is that Ahmed, let's say Ahmed, we don't know he's a smoker or not. There's a probability that he is, yes or no. There's also a probability that if he is, he will develop lung cancer, and he can also develop lung cancer even if he's not a smoker, right? So there's a lot of things going on. What they're asking when they say find the probability that he develops lung cancer given that he smokes, right? Let me put some numbers on it for you. Let's imagine there's 100 people. and let's say 10 of them smoke, okay, and 90 of them do not smoke. So this is no and this is smoking. Now let's say from the smokers, 9 people will get cancer. I'm overdoing it here. And no cancer is 1 person, right? And let's say from the non-smokers, there's 1 guy who'll get cancer and there's 89 who will not get cancer, okay? So what they're asking, when they're asking what's the probability of somebody getting cancer? Well, somebody getting cancer means 9 people, 1 person out of 100. That's 10 people out of 100. But if they say 10 people out of 100 is 10%, right? But if they say, what's the probability of somebody getting cancer given that they smoke? Well, now all I'm looking at are the smokers. I'm only considering the smokers. And in this case, what's the probability of somebody getting cancer given that they smoke? Well, that's 9 out of 10, right? That's 90%. Right? So if we're looking at everybody, it's just a 10% chance. But if we're looking at the smoker, given that somebody is a smoker, the probability is way, way higher. It's 90%. So when you're talking about conditional probability, that's what this is called. It means you're narrowing your universe. You're only looking at the given condition, which in this case was smoker. Of course, these numbers are they're just nonsense from my mind. Smokers are jokers. Of course, don't smoke. It's bad for you. Okay, so that's the end of the video. As you guys know, I offer an online workshop for EmSAT. If you need private lessons, definitely add me on Instagram at WiseGuysUAE and just DM me there. Please like the video and make sure to subscribe to the channel so that you'll get notified when I drop a new one. If you have any questions or comments or suggestions, please put them below. I love hearing from you guys, and I'll see you in the next video soon. Good luck.